so page 20 in your module 1 packet, we're on 1-2 still. This is day 3 for that. Remember, if you're absent, I am recording these and posting them by the day in Google Classroom, so you can stay caught up even when you're not here. You're also always welcome to join the Zoom. I try and have it on every hour, so if you get on during the 2nd, 3rd, or 7th hour, you will be joining us live for 8th grade math. Also, we have this great new tool online. So when you log into Clever, and instead of going to Alex, if you choose to go to the reveal site, you can check the calendar, and I will do my best to be sure we're on the right spot together. So we started with the product of powers, right? We're doing laws of exponents. We started with the product of powers. Yesterday, we dove into the quotient of powers rule, and we're continuing with that in order to divide monomials. So we've kind of added on a little bit of a layer every time. So we had multiple bases yesterday, and today we have coefficients with our division quotients here. So I can use the laws of exponents to multiply and divide monomials with common bases. So it's important that we can multiply and divide using the laws of exponents. We are all the way on example 7. One more, 2 more. All right, here we are. So page 20, do you see where it says example 7, divide monomials? That's where we are. We are to simplify 12w to the 5th power divided by 2w. So your notebook is so fantastic that it takes you through these steps. There's not a whole lot for you to write, so I really want you to be focused on looking and learning right now. So first we write the expression. They showed that. Then we use the associative property. Because these things are being multiplied, we can multiply them in any order, and we can also associate them any way we want. So we can group them together any way we want, right? Who you associate with is who you're in a group with at school. That's where we get the associative property from. So they're associating the two. You guys remember what those things are? Business in the front are what's that big word? Numbers. Coefficients, right? So they're associating the coefficients and the variable terms. So your first step now is to divide the coefficients. So what is 12 divided by 2? 6. So we do need to write that in our packet. You notice they left that spot blank for us, so we do need to put a 6 there in our packet. All right, you guys are awesome. I'll have something to write without following along, and so attentive answers and Xander, right? So now we need to use our quotient of powers property. So if we're dividing things that have the same base, we do what with the exponents? Add or subtract? When we divide, we're going to subtract the exponents, and always the top minus the bottom. When we just have a W, we have to remember that that is to the 1st power, right, Grace? So we have 5 minus 1. What is 5 minus 1? 4. So we have W to the 4th power. I'm going to write that down, and our coefficient is the same. It is 6. And that's what they're saying here. So, in other words, 12w to the 5th divided by 2w equals 6w to the 4th. Any questions about how they got from point A to point B? No, we're okay? Fantastic. So, why were the coefficients divided, but the exponents subtracted? Because they're different bases. Hey, those are pretty good ones. We can divide numbers. We can't divide what we don't know, but if they're the same base, we can simplify them. Because the same base means there are that many factors, right? Remember, if we were writing this out, we could write out 5 W's and 1 W on the bottom and cancel out 1 W from the top, leaving 4 on the top, right? Remember drawing that out yesterday. Okay, so here's our check. We are doing this check problem in your packet. It says 24K to the 9th divided by 6K to the 5th. So take just a second, make sure you're understanding and completing that check with us. All right, so you should have taken your coefficients. You can associate them. 24 divided by 6 times your party in the back, right? What's 24 divided by 6? What did you get, William? What's the question? What's 24 divided by 6 is 4. Thank you. And then we know K to the 9th minus 5 is 4K to what power, everyone? 4, thank you. Do you see how we got from point A to point B? All right, that's all we're doing for dividing monomials. There's an extra example here that I would like you to write on your page there on the bottom of page 20. So we have 15y to the 12th divided by 5y to the 4th. 15y to the 12th divided by 5y to the 4th. We start with our business in the front. We can divide 15 divided by 5. Then we use our quotient of powers property to figure out and simplify y to the 12th divided by y to the 4th. Can we do that? All right, so what's 15 divided by 5? 3, fantastic. And then if we were writing out our quotient of powers property, we would have y to the 12 minus 4. What's 12 minus 4? And 8, excellent. So we have 3y to the 8th. That was our extra check. And be sure you're writing down the problem, because remember, we don't have the problem listed in our packet. And if you just write down 3y to the 8th power, how is that going to be helpful to you to refer back to? No, right? Okay, now we're going to come back to the apply, but you're going to finish page 23 right now. So these last few examples on page 23, there's just 3 more that you're going to have about 10 minutes to complete before we move on. So we're going to do numbers 7, 8, and 9 on your own. Try those. We'll go over them in just a few minutes. Number 7, it says to refer back to example 5. The question is, a publisher sells 10 to the 6 copies of a new science fiction book and 10 to the 3rd power copies of a new mystery book. How many times as many science fiction books were sold than mystery books? Remember that how many times tells us we have to divide to see how many times 10 to the 3rd will go into 10 to the 6th. If we look back at example 5, we see that they divided those 2 numbers, right? How many times longer as to why? They took the bigger divided by the smaller. Same with our check, right? They took the bigger divided by the smaller to see how many more times it was as great, right? So we should be able to do that by saying 10 to the 6th divided by 10 to the 3rd, which is equal to 10 to the 6 minus 3 equals 10 to what power? 3. Power of 3. Good. All right. Number 8, it tells us is like example 7, which is what we just did. So we have to look at our coefficients first. Remember that fraction bar means divided by. What's 45 divided by 9? 5. Then we can associate our x terms. Remember using our quotient of powers property, we have 15 minus 10. What's 15 minus 10? 5. So I have x to the 5th power. 5x to the 5th power. Is that what you guys got? Remember, when our letters and numbers are next to each other, that's multiplication. So we can associate them because it is multiplication. Now, when we simplify this equation editor,
When I'm going out.
All right, so we can associate our A's and our C's. So what is 4 minus 2? What's 4 minus 2? 2. So A to the 2nd power. And what is 6 minus, wait, what exponent goes to that C? 1. Good. So what's 6 minus 1? 5. All right, now we have to figure out how we're going to apply. So I'm going to turn back in my packet to page 21. All right, these apply problems are probably the most important. You need to learn to think for yourself, right? The processing speed of a certain computer is 10 to the 12th instructions per second. A second computer has a processing speed that is 10 to the 5 times as fast as the first computer. A third computer has a processing speed of 10 to the 15 instructions per second. Which computer has the fastest processing speed? All right, so we have to make sure we're understanding exactly what the question or problem is to solve, and we may want to read it at least 3 times. So what's the context of the problem? What are we trying to find out? William?
Which one has that faster?
Which one is faster, and how many computers are they looking at?
3.
3 different ones. So let's read through and make sure we understand. The processing speed of a certain computer is 10 to the 12th instructions per second. Do we need to do anything to find out the speed of the first computer? No, they gave it to us. So computer number 1 is 10 to the 12th per second. They're all written in per second, I believe, so we don't have to worry about that. A second computer has a processing speed that is 10 to the 5th times as fast as the first computer. So what do we need to do to find the speed of the second computer? Read that sentence again. A second computer has a processing speed that is 10 to the 5th power times as fast as the first computer. So what am I doing to the first speed? Multiplying, because it says it is 10 to the 5th times as fast. So the speed of the second computer is the speed of the first times what? 10 to the 5th. Well, what is 10 to the 12th times 10 to the 5th? 10 to the, what do I do if I have like bases that are being multiplied? I add them. When they're being multiplied, we add them. A third computer has a processing speed of 10 to the 15 instructions per second. Do we have to do anything to the third to figure out the third speed? A third computer has a processing speed of 10 to the 15 instructions per second. So do we have to do anything to that, or are they just giving it to us? They're just giving it to us. So now we have the speed of all 3 computers. So which computer has the fastest? 10 to the 12th, 10 to the 17th, or 10 to the 15th?
10 to it, so
10 to the 17th, excellent. So we wrote speeds for each the highest exponent of the like bases was the highest speed. So we should also be able to figure out how much faster it was than the others if we were dividing, but we're not gonna worry about that right now. But the second computer was fastest. We had to use the product of powers though to figure out that speed. So I did not write that stuff down, but we did use it. Okay.
Row speed. For
Do I have to do screens? All right, so we just looked at that. Here is your extra applied problem. Liam. Oh wait, maybe we didn't do the check on it. Go back. The check is at the end. So the check, it's okay, you're gonna be okay. Relax. So on the top of page 22, we're gonna check our understanding of how we figure these things out. All right, Bolivia has a population of 10 to the 7th people. Wait a second. Go. 22, page 22. Thank you for your permission. All right, on the top of 22. Bolivia has a population of 10 to the 7th people, while the population of Aruba is 10 to the 5th power people. The Philippines, listen, this is where this gets similar, right? The Philippines has a population that is 10 to the 3 times greater than Aruba's. So what are we multiplying by 10 to the 3? Which population, Bolivia or Aruba? Aruba, and Aruba's population was what? 10 to the 5th. So I'm going to write down that 10 to the 5, and I'm multiplying it by 10 to the 3 in order to get the Philippines population. What is 10 to the 5th power times 10 to the 3rd power? 10 to the 8th power, not 8. That'll be a very small population, right? All right, so now we can compare them. One has 10 to the 7th, one has 10 to the 5th, and one has 10 to the 8th. So it's asking us, which statement is true about the population of the 3 countries? Does Aruba have the least population? Yes. Does Bolivia have the greatest population? No. Does the Philippines have the least population? No. Does Bolivia and the Philippines have the same population? No. So it had to be A. Aruba has the least population.
Aruba.
We probably could have been able to conjecture that without even solving the problem though, right? Because Aruba was less than Bolivia and the Philippines was 3 times the amount of Aruba, so we knew they were less than the Philippines too. So that was a really silly question to give us, in my opinion. All right, here's our extra applied problem. So we do have some extra space on our paper here to complete this. Let me move this window out of your way. Liam is recording the lengths of samples of bamboo. Sample A is 10 to the 5th power centimeters long, and sample B is 10 squared centimeters long. Sample C, here it is, has a length that is 10 squared times longer than sample B. So what am I multiplying by 10 to the second? Sample B, which is also 10 to the second. So what's 10 squared times 10 squared? 10 squared times 10 squared is equal to 10 to the 2 plus 2, which is 10 to the 4th. That is our product of powers rule, right? So which sample is the longest? 10 to the 5th, 10 squared, or 10 to the 4th? 10 to the 5th, which was sample A. Answer A again. All right. Too fast, too slow? How are we feeling? And you awake? Yeah. All right. So this leads us to the back side of our problem. So we are going to be working on 24. So refer back to our examples as you're going through page 24. So lots of time on your own now to figure out 24. I think I will give you the rest of the hour. That way we can go over it to start. Yes, we are finishing up the whole page. You may not get the whole page done today. That will probably be our warm up tomorrow in place of Alex if we do not. Okay. So page 24. Be sure you are following the examples. If you get stuck, don't just sit there and stare at your page. You go back and look at what we've done, right? Read through them 3 times. I understand the first time we read through a problem, we always sit there like, what was that, right? So read through it a couple times. Get it figured out. We're at a voice level of 0 and we are getting this done.